The Once and Future Present, Episode 17, Scientific Revolutionary. Hey everyone, welcome back to HETS, The Once and Future Present, the AP Euro podcast from Hammer History Productions. I'm your host, Casey Brooks, and today we're tackling a big question. Was the scientific revolution actually revolutionary? Like, was it really a turning point in how people saw the world, or is that just a label historians added later? To help me figure this out, I'm joined by Professor Theo, who specializes in social and intellectual history. Welcome back.
Thanks, Casey. It's great to be here. This topic is one of my favorites because it really forces us to ask, what do we mean when we say something is revolutionary?
And also joining us is Dr. Morgan, expert in political and economic history. Hello again.
Hello, Casey. I'm excited for today's conversation. The scientific revolution shaped the modern world, but whether it was truly a revolution depends a lot on your perspective.
So let's start simple. What do historians actually mean when they debate whether the scientific revolution was revolutionary?
Most of the debate comes down to whether the changes in science during the 16th and 17th centuries represent a sudden break with the past, or more of a gradual transformation. Some historians see it as a true revolution, a sharp turn that reshaped human understanding. Others say that interpretation is too simplistic.
Right? And this ties into a bigger issue in history. Periodization. That's the practice of dividing the past into named blocks, like the Middle Ages or the Enlightenment, or in this case, the Scientific Revolution.
Wait, you mean historians argue about the names of time periods?
Absolutely. Periodization always involves judgment calls. When we say a revolution happened, we're deciding where a story begins and ends, and that can leave out a lot of messy overlap and nuance.
For example, calling it a revolution suggests there was a clear break. But people didn't wake up one day in 1600 and suddenly do science differently. As Stephen Shapin points out, there were lots of overlapping methods and ideas, and the term scientific revolution itself wasn't coined until the 20th century.
So even the timeline is a little fuzzy?
Very much so. Some of the roots of what we call modern science go back to medieval thinkers, and many of the consequences took centuries to unfold. Period labels can be useful, but they also shape how we interpret change.
And that's why some scholars, like Shapin, are skeptical of calling this period a revolution. He worries the label hides as much as it reveals.
Let's break down the arguments in more detail. What does Herbert Butterfield actually say in his essay?
Butterfield offers one of the strongest endorsements of the scientific revolution as a true break with the past. In his view, thinkers like Bacon and Descartes weren't just making small updates. They were rewriting the rules of how people learn about the world.
Right, and Bacon especially wanted people to stop just relying on old books and start doing actual experiments. He said we should observe nature directly, right?
Exactly. Bacon promoted the idea of collecting data first, then building theories from there. It was a rejection of the old method of reasoning from established truths.
And Descartes, on the other hand, pushed for a deductive approach. He wanted knowledge to be built from a foundation of clear and logical first principles. They disagreed on method, but both were saying, don't just trust the ancients, use reason.
What about Galileo? He's not mentioned as much in their arguments, but didn't he also challenge traditional thinking?
Yes, and Butterfield sees Galileo's telescope not just as a tool, but as a challenge to authority. Galileo said, "Look for yourself," rather than just trusting Aristotle or scripture. That's revolutionary.
And Newton pulled it all together. His law of universal gravitation said the same physical laws applied to apples falling and planets orbiting. Butterfield treats that unification as the defining moment of the revolution.
So science started looking like a universal language, based on math and rules instead of tradition or faith?
Exactly. Butterfield believed this intellectual transformation extended far beyond science itself. He argued that once people believed reason could explain nature, They started thinking it could improve society too.
That's where Butterfield connects the dots to the Enlightenment, to secularism, and even to the Industrial Revolution. He says the confidence that science inspired spilled over into every corner of life: government, economics, even personal identity.
That's a pretty bold claim. So for Butterfield, the scientific revolution is like the engine of modern thought.
Absolutely. He even suggests it was more transformative than the Renaissance or the Reformation. For him, it marks the beginning of modernity, a world shaped not by faith or tradition, but by investigation and innovation.
That gives me a much clearer picture. Let's see how that compares to the next view.
So let's talk about Edward Grant's perspective. Unlike Butterfield, he doesn't see the scientific revolution as a sudden break. Instead, he emphasizes the deep roots that made it possible.
Exactly. Grant argues that the medieval period, especially from about 1175 to 1500, was crucial in laying the foundation. He points to the massive translation movement of Greek and Arabic scientific texts into Latin, which brought back thinkers like Aristotle, Galen, and Ptolemy into academic discussion.
So he's saying that medieval scholars were already doing science, in a way?
Yes, especially in the universities. Grant talks a lot about how natural philosophy was taught as part of the standard curriculum. Thinkers like Buridan and Orsmay were asking questions about motion and the cosmos that later scientists picked up on.
And it wasn't just about repeating Aristotle. These medieval scholars debated, questioned, and sometimes contradicted him. They used logical analysis, hypothetical reasoning, and even what Grant calls thought experiments to explore natural laws.
So, in a way, Grant sees Copernicus and Galileo as building on that earlier tradition?
Exactly. He sees them not as rebels, but as heirs. For example, Copernicus was trained in a university system steeped in scholastic methods. Grant argues that the very idea of challenging Aristotle came from that environment.
That's interesting. It kind of flips the script on the idea that medieval thinkers were anti-science.
It does. Grant wants us to recognize that medieval Europe had something unique. A network of universities with some intellectual freedom, a shared curriculum, and a belief that natural knowledge could be pursued systematically.
And that's where he sees the continuity. For Grant, the scientific revolution wasn't a rupture. It was a long process of development that eventually reached critical mass in the 17th century.
So for him, it's still a revolution, but it's a slow-burning one?
Precisely. And it's one that makes more sense when we look backward, not just forward.
That really helps frame the contrast with Butterfield. Okay, let's dive into the third view.
Stephen Shapin is the most skeptical of the three. He doesn't say that nothing happened, but he questions whether the idea of a scientific revolution is even a helpful label.
That's right. He starts with that provocative line. There was no such thing as the scientific revolution. He doesn't mean the discoveries weren't real. He means that the label creates a tidy story that the history doesn't really support.
So what does he think actually happened then?
Shapin argues that what we call science in the 17th century wasn't one coherent movement. It was a mix of practices, traditions, and beliefs that varied widely depending on where you were and who you were. He looks at case studies to show how diverse and messy early science was.
Take Robert Boyle, for example. Shapin uses him to show how science was as much about performance and persuasion as it was about discovery. Boyle conducted public experiments to demonstrate his credibility. He was a deeply religious man, and he saw his scientific work as glorifying God.
That's interesting. So science wasn't totally separate from religion back then?
Not at all. In fact, Shapin spends a lot of time showing how closely tied science was to religious belief. Isaac Newton, who's often treated as the icon of rationality, wrote extensively on theology and alchemy. He spent more time on those than on physics.
And Chapin makes another point. These thinkers didn't call themselves scientists. That word didn't even exist. They called themselves natural philosophers. Their work included everything from astronomy to astrology, and from chemistry to alchemy.
So even Newton believed in alchemy?
Yes, and that's Shapin's point. The boundary between what we now call science and what we now call pseudoscience wasn't clear at all. Chapin is asking us to think about how much of what we believe about the past is shaped by present-day ideas.
That's where the critique of periodization comes back. Chapin says that the idea of a scientific revolution was invented by later historians who wanted to tell a story about progress. He sees that story as more about modern values than historical reality.
So for Chapin, it's not that science didn't change, it's that we've wrapped it in a neat package that might not be honest to how it actually happened.
Exactly. He's not saying there weren't breakthroughs, but that calling it a revolution hides the complexity and variety of the time.
That really shows how each historian has a totally different way of thinking about this. Butterfield sees a dramatic break. Grant sees a long evolution. And Chapin thinks we're asking the wrong question in the first place.
And that's why historiography matters. It's not just about what happened, but about how we interpret and frame what happened.
And how those frames shape what questions we ask next.
Before we close out completely, let's take a moment to really compare these views.
That's a great idea. So let's start with how each historian defines the word revolution. For Butterfield, a revolution means a sharp break with the past, something that fundamentally transforms how we see the world. He focuses on the intellectual methods and long-term consequences.
Grant, on the other hand, defines revolution more as a culmination. He sees it as the visible turning point of a much longer process. His revolution depends on deep continuity with earlier traditions. He's really emphasizing institutional and curricular development.
And Chapin questions the word revolution altogether. For him, using that term imposes a modern framework onto a past that was messier and less unified. He sees the label as a way we shape history to fit our ideas about progress.
Right, and that difference in definition explains a lot of their conclusions. Butterfield says yes, this changed everything. Grant says yes, but it was centuries in the making. And Chapin says we shouldn't even be asking, was it a revolution? Because the label oversimplifies a complicated time.
We could also compare how each historian treats figures like Newton or Galileo. Butterfield makes them into heroes of a new scientific era. Grant shows how they grew out of medieval traditions. Chapin reminds us they were also deeply embedded in their religious and cultural contexts.
So it's not just what they say, it's also how they say it, and what kind of evidence they think matters. Butterfield reads the published works and takes the claims seriously. Grant looks at university structures and curriculum. Chapin looks at diaries, letters, and social behavior.
And those choices shape the stories they tell. That's one of the most important lessons in historiography.
I can see now how this conversation isn't just about science. It's about how we understand change and what we count as progress.
Exactly. The scientific revolution isn't just an event. It's a window into how history is written.
I want to remind listeners that Hammer History Productions has music albums for both AP Euro and AP US history. Historically accurate songs to help you remember key concepts. You can find them on Spotify, YouTube Music, Apple Music, and most major streaming platforms. Thanks again to Dr. Morgan and Professor Theo for being here. And thank you all for listening. Stay curious, think critically,